Ciao friends and welcome to a new video from SQL BI. In this video, I want to elaborate on the topic of ranking. Users love ranking. You always want to know the position inside a list of products, customers, brands, whatever. You have a sorted list and you want to know the position 1, 2, 3, 4. DAX offers you several ways to compute ranking. Rankx, the classic way of ranking, a function that nobody ever loved because the syntax can be hard to understand and it is extremely powerful, but it lacks some basic functionalities and it's hard to use. Then we have the rank function, the new function introduced with the window function, simpler, easier, sometimes a bit more powerful, even though it lacks some of the features of Rankx. Spoiler alert, rank is your best friend because the features it lacks are really useful in very exotic scenarios. And then you have also the option of using rank inside the visual calculation. More flexible in some way and not so powerful in other ways. So there are advantages and disadvantages in using each of these functions. So the topic of the video is elaborate on the topic in order to understand what is the best way to produce a ranking in your specific scenario. Let's get started. Let's start by looking at this simple matrix. I'm slicing by product brand, I'm showing the sales amount, and I have already sorted the table by sales amount. So I want to produce a ranking, 1, 2, 3, 4, 5, grow, starting from the largest value. The easiest way is just to use Rankx. Well, not the easiest way, probably just the most classical one is to use the Rankx function. So we use a Rankx. Rankx requires a table as the first argument. We are slicing by brand, so we do all selected over a product brand. And we sort it by sales amount. The measure just works and it produces a nice result. 1, 2, 3, 4, 5 up to 11. Then we have this one that is not really cool. The reason is Rankx computes the ranking of 4 million against a table that contains the values of sales amount by brand, so it always shows 1 at the grand total. And we don't want to see that total. So a very common pattern is to use isInScope to say, well, I want to show the value only if the product brand is in scope or if there is only one value for the product brand. By doing that, I get rid of this 1 at the total and the code works. This is a very common pattern used by a lot of DAX developers all over the world in their semantic model. Rankx works nicely, but as I said, requires a bit of attention to details. There's the new rank function. You can just create a ranking using rank. Rank is a bit simpler from the point of view of the syntax because you can just use all selected product brand, order by sales amount. The syntax is a bit easier because you provide the table that you want to use to produce the ranking and then the order by in sales amount. And with rank, all selected product brand order by sales amount. Oh yes, that's rank, not Rankx. Okay, rank all selected product brand order by sales amount. And if I use it here, the ranking is the opposite. Rankx by default starts from the largest value. Rank by default starts from the smaller value. So in rank, we need to use order by and we need to specify the ascending. Not a big deal, but this way we have the same ranking that we had with Rankx. There is an advantage in using rank. Look here, there is already a blank for the total. The reason is not easy to understand because it involves applied semantics. Basically, rank ranks a row, whereas Rankx ranks an expression. So because rank ranks a row, it needs to have a current row. It produces a value only if there is a brand, if there is one value among the product brands which are part of the source table. If there's no such a value, rank already produces a blank. So that's good news because the code of rank is simpler than the code of rankx. You have fewer details to worry about. There is a third option that is still using rank, but this time in a visual calculation. Because we created a measure, but we can also create the same using a visual calc. So let's go for a custom visual calc. Let's call it visual rank. And we do a rank. This time, instead of using all selected product brand, we can use the special keyword rows. Rows identifies whatever is on the rows of the current matrix, avoiding us the need to use a specific column name. So we rank based on the rows based on the sales amount. That should be order by sales amount. That produces again the opposite ranking. So in visual rank, where are you visual rank? We need to provide sales amount descending. And now we have the very same result with the drawback. Look here, we have 1 at the total. Why that? Because rows includes all the rows of all the levels. So it does not only include the rows brand by brand, it also includes a row for the total, which will be ranked accordingly. So as it happened with rankx, in a visual calc, we need to get rid of the totals. And this can be done in a slightly different way. We can check if is at level brand, then we produce the result. So we produce the result only if we are at the brand level or below. And by doing that, now we have 1, 2, 3, 4, 5, 6, 7, and the total is gone. What is, first of all, the advantage or the disadvantage of using visual calculation against using a measure? Because rank and rankx, they are both measures, whereas visual rank, that is a visual calculation. Well, visual calculation have some advantages. Probably the most important one is that you can use rows rather than using product brand. In a measure, you need to hard code the column on top of which you are producing the ranking. So if you look at the two measures, both rank and rankx, we need to use product brand here and product brand here. So the measure works only for product brands. Both rank and rankx, they have the same problem. Whereas in a visual calculation, things are a bit easier because you can reference rows, and whatever is on the rows will be shown. Still, we need to use isAtLevel brand if we want to get rid of the total. So in some way, also the visual calculation needs to have the column used in the visual inside the code. But the advantage of visual calculation is that they will work even though you use a different column. Look here, I'm using brand. If I get rid of brand, where are you, brand? Okay, let's say I get rid of brand and I use the category. I get an error, and the error is because visual rank is still referencing brand. So let me edit the calculation. And instead of using isAtLevel brand, we use isAtLevel category. I don't need to change the code of rankx, and this produces a rank by category. So that is computing correctly a rank by category. Whereas both rankx and rank, they just produce a blank result. So if you use a measure, you need to hard code the column you use in order to produce the ranking. If you use a visual calculation, you don't need to do that. That's an advantage for visual calculation. However, visual calculation also have drawbacks. The first one, the code is in the visual, so if you want it in a different visual, you need to repeat the code, and they will leave us two different calculations. And the second disadvantage is a bit more subtle. A visual calculation can only see the values that are in the current visual, and sometimes this is a limitation. In order to show you this, let me go back to slicing by brand, so we also have the other calculation, and let's fix again the visual calc. We use product brand. So we now have the same value everywhere. However, I might be interested in computing a global ranking. Look what happens. If right now, these are all computing local ranking. If I select only two brands, they will be ranked 1 and 2. 1, 2, 3, 1, 2, 3, 4. So the ranking that is being computed is local to the selection. But if you look at Contoso, for example, right now it's ranked 3, but if I don't have any selection, Contoso is actually ranked 4. And maybe, regardless of the selection made by the user, I want to show the global ranking. This can be done easily both with Rankx and Rank, because I can go in Rank, and rather than using all selected product brand, I can just use all product brand. And for Rankx, instead of using all selected product brand, I can just use again all product brand. So I ignore the filter coming from the outside, and I always use the full table to produce the ranking. With Visual Rank, I cannot do that, because if I make a selection of just a few brands, you see that Rankx and Rank now, they compute a ranking that is global, and they no longer show 1, 2, 3, 4, they show the ranking of the brand considering all the brands, even the ones that are not visible. Rank cannot do that. Rank does not have the option of seeing brands which are not part of the current visual. So visual calculation have this limitation. Maybe this is not important to you because in your report you don't need to compute global ranking, and so that's it. You can go for a visual calculation. It's simple, it's easy, and it produces good results. But if you need to compute global ranking, then visual calculations are not an option. But you still have to decide between Rank and Rankx. As we have already seen, Rank is easier, the syntax is simpler, and it has several advantages. The first and most important one, in my opinion, is that Rank by default can rank on multiple columns. You can rank by sales amount, and by sales amount and product name. If there are ties in the sales amount, you use the product name as the second ranking option. Rankx does not have this option. Rankx ranks on only one column. Therefore, if you need to compute ranking based on multiple columns using Rankx, you can do that, but it's really complicated. We recorded a video that explains how to do that, and trust me, that's not the kind of code you ever want to write. Rank performs this automatically, so that's a very good advantage. The second important advantage is that it shows blank whenever needed, and again, that's a good thing. So Rank, and besides, it's also newer. So it's probably better optimized and works well with window function. So Rank is definitely my default choice when it comes to compute ranking. Still, there are some disadvantages, or if you prefer, scenarios where Rankx can compute a value, whereas Rank cannot do. And basically there are two categories. The first one is the fact that Rank, being a window function, uses apply semantics. Apply semantics is kind of complicated. And if you are not familiar with apply semantics, we recorded a video about apply semantics, and I suggest you take a look at it because it might be useful to understand exactly how it works. Apply semantics also means that Rank cannot rank on top of a variable that contains columns with no data lineage, because apply semantics, in order to work, requires data lineage. We will see that later. The second problem or limitation is that Rank cannot rank on top of a separate table. Rank ranks rows in a table. So you need to have a table containing rows, and you rank a specific row. Rankx, on the other hand, ranks a value against a table. Therefore, you can rank based on a different table than the one used to compute the lookup table. Let me show you this with an example, because that makes it much more easier to understand. Let's say that I have my report brand and sales amount, and I have a configuration table, gold, silver, and bronze, with 3 limits. If the value is above 800,000, I want to mark it as gold, 1. If it is above 300,000 but below 800,000, it's silver, and bronze if it is greater than 0, whatever value that is. Now, believe it or not, you can compute the key, so the level at which you want to tag each value, by using rankx, because rankx can rank this value against this configuration table. And let me show you this with a measure. Let's call it level. You can use rankx. You use as the configuration table the table that I called level. Inside the level table, you need to have a column containing the value that you want to produce. You want to use to produce the list of boundaries, and this is the level limit. And as I said a couple of times already, rank ranks an expression. The expression can be sales amount. This is the infamous third argument of rankx. A lot of people hate the third argument of rankx because they don't think at rankx as ranking a value. They think rankx ranks a row. But actually, rankx ranks this value against a table that contains out of levels the limits. So the two expressions, the second and the third, can be different. Mostly they are the same, but that's not necessary. You can use different values. So writing the code this way, rankx, what's wrong here? The syntax for level is incorrect. I think I need to quote level. Okay, that's it. Not very smart to use a keyword as a table name, but I did it, so I need to pay the price. I use a level here, and it produces 1, 2, 3, and then 1. So it just works. You cannot do the same with rank, because rank simply cannot rank two different expressions. So rank would rank a row. I could rank levels inside levels. I could rank brands and sales amount inside a table containing brands and sales amount, but this third option is just not an option. Is this a real limitation? Well, not really, because I bet no DAX developer would ever write code like this. You can do that, and it's interesting to know that you can use rank to perform this kind of lookup, but it's not necessary to do that. You can just use a simple iterator. So you can just create a new measure. Let's call it level 1. When you choose a simple iteration, you find the minimum value out of a table that filters a level where level limit is less or equal than the sales amount. This filters out from the table the rows which are higher, and then out of this table I just return the level key. Now this expression just uses a regular iterator, a filter, so much simpler DAX code, and the result is the same as using rankx. I still obtain 1, 2, 3, same value using simpler DAX code. That's the reason why I honestly don't think that the capability of ranking a value on top of a configuration table is really so important for rankx. I bet no developer actually uses this feature. But there is a scenario where rankx is still really needed. That is, whenever you want to rank on top of a variable that only contains columns created in DAX code and not model columns. The reason is, again, apply semantics. Let me show you with another demo. This time I'm not going to write the code because it's not so interesting to see. Let's look at this code. I create the source table that contains all the selected product brands with two columns, brand and sales amount. So the source table, if I return the source table this way and I run it, I obtain a table that contains the brand and the sales amount. And I want to compute, to use summarize columns and produce a table that contains the brand, the sales amount, and then the ranking on top of this table. If I run the code right now using rank, I use this table, source table, as the table to use for the ranking, order by sales, and I compute the result. It's going to work nicely. The thing is, it works because of apply semantics, because summarize column is iterating by brand, and the brand is the same column that it appears in the source table. So the engine is able to detect the current row by identifying that the filter context contains a brand, and the brand is part of the variable. The brand is a model column. That's how apply semantics finds the current row, because it checks that the table used at the source table contains columns that are being filtered in either the filter context or the row context. But if the table that I'm using, rather than containing product brand, contains a column with no data lineage, that is going to be a problem. In order to do that, I can just break the lineage, adding an empty string. The source table is not going to change because I just added an empty string to the product brand. So I run it and I still obtain the very same result. With an important difference, now brand no longer has the lineage of product brand. Therefore, my code will not work because rank will try to match the product brand with a variable that does not contain the product brand. And if I run it, I get an error. Rankx relation parameter only contains column added by DAX table function. At least one column in your table needs to be a model column. And that is the column used for the matching, so you need to pay attention to this detail. Again, as I said, apply semantics is not easy and hides some shenanigans. In such a scenario, Rankx would just work. I can do a Rankx over the source table. Source table already contains the sales amount. I cannot use order by sales. I use the first argument, sales, that is the column in the table used to build the lookup table, and then I use sales amount as the value to rank. And if I run it this way, it just works and produces a ranking. Therefore, Rankx has this feature that is missing in rank. That is not common, but if you ever face such a scenario, then you know that you need to stop using Rankx for that specific measure and stop using rank for that specific measure and rather use Rankx. So, as you have seen, you can either use visual calculation, rank, or Rankx. Visual calcs have the advantage of being very simple. The disadvantage that you can only see the values which are present in the current visual. So that's a limitation. Sometimes it's an advantage. It avoids you from using all selected, but from a technical standpoint, it is a limitation. Between rank and Rankx, rank is a clear winner. It's easier, it's probably faster, it's better, the syntax is easier to use. Rankx is the old way. It's a bit more powerful in some scenarios because it has the ability of ranking an expression against the lookup table, but to be honest, this feature is really rarely used, so you will probably never miss it. Whereas you will miss the capability of ranking over multiple columns. So go for rank for all of your ranking needs and only revert to Rankx if strictly needed because of your requirements. Enjoy DAX!